Today we have chemistry, and the topic for discussion is the kinetic theory of matter. Matter, as you all know, is anything that has mass and occupies space. The kinetic theory of matter. Number 1, introduction. Meaning of matter. Matter is anything that has mass and occupies space. Number 2, the nature of matter. Matter is made up of particles which are constantly moving, hence possesses kinetic energy. States of matter. Number 1, matter exists in 3 states: solid, liquid, and gas. Each state has different degree of movement. Number 2, solid. The particle could be molecules, atoms, or ions. The particles of a solid are closely packed, hence they have a fixed shape. Number 3, the particles of a solid vibrate over a fixed position with a strong force of attraction. The particles of a solid is orderly arranged, hence solids have a fixed volume. You can see that the particles of this solid is highly ordered arrangement, and they are also closely packed. Number 4, liquids. The particles of a liquid are slightly further apart than those of the solids. Liquids can vibrate, rotate, and translate. Since they have more kinetic energy, they are hard to compress. They have a definite volume, but take the shape of the container. The particles of liquids are further apart than solids, as can be shown by this drawing. Gaseous state. The particles of gases have much more kinetic energy. The cohesive forces are negligible. Hence, they are free to move in all directions. They can only be restricted by the walls of the container. No definite shape and no definite volume. They can easily be compressed. Particles of gases are further apart than in solids and liquids, as can be shown by this diagram. Number 5, change of state. Temperature change can cause matter to change state. If heated, the particles acquire more kinetic energy and becomes more energetic. If cooled, the particles becomes less energetic, melting. When a solid is heated, the particles acquire more kinetic energy. At the melting point of a solid, the force of vibration overcomes the binding forces and the crystalline structure gives way. The particles are free to move. Evaporation. When particles of a liquid that are more energetic come into the surface, it breaks away from the attractive force of other liquid particles and escape into the surface, that is, vaporizes. The average kinetic energy of the liquid is lowered, hence the temperature of the liquid drops. Evaporation occurs at all temperatures. The rate of evaporation depends on temperature and the type of liquid. Condensation. As the vapor pressure increases, the particles move on all directions. Some of the particles drops into the liquid and condense. Saturated vapor pressure occurs when the number of particles evaporating is equal to the number of particles condensing. Liquids boil at a particular temperature called boiling point when the saturated vapor pressure equals the atmospheric pressure. Freezing occurs when the particles of a liquid is cooled. It loses kinetic energy and the cohesive forces increase as the liquid turns to solid. This is a graph showing the change of state from solid to liquid and to gas. We can see from solid to liquid is melting, and from liquid to gas is evaporation. From gas to liquid is condensation, and from liquid to solid is freezing. Number 6, phenomena supporting kinetic theory. The phenomena supporting kinetic theory are Brownian movement, diffusion, and osmosis. Brownian movement was observed by Brown when he was examining a bowling green suspended in a drop of water under a microscope. Diffusion, the movement of particles of solid from region of higher concentration to region of lower concentration. Diffusion occurs fastest in gases and slowest in solids because gases have more kinetic energy than solid and liquid. Example 1. 1. Evaporation. 2. Sublimation. 3. Diffusion. 4. Brownian motion. Which of the above can correctly be listed as evidences for the particulate nature of matter? A. 1 and 3 only. B. 2 and 4 only. C. 1, 2 and 3 only. D. 1, 2, 3 and 4 only. Answer to example 1. 1 and 2 are change of state, which also supports the kinetic theory of matter. 3 and 4 are movement of particles, which as well supports the kinetic theory of matter. Therefore, the answer is option D, 1, 2, 3, and 4. Example 2. Which of the following properties is not peculiar to matter? A. Kinetic energy of particles increases from solid to gas. B. Random motion of particles increases from liquid to gas. C. Orderliness of particles increases from gas to liquid. D. Random motion of particles increases from gas to solid. The answer is A. Kinetic energy of particles increases from solid to gas. This is because the solids have less kinetic energy and the gas has more kinetic energy. B. Random motion of particles increases from liquid to gas is not true. It increases from solid to gas. C. Orderliness of particles increases from gas to liquid. It is not true. Orderliness of particle increases from gas to solid. D. Random motion of particles increases from gas to solid. It is not true because random motion of particles increases from solid to gas. Example 3. The droplets of water observed around a bottle of milk taken out of the refrigerator is due to the fact that the dash A. Water vapor in the air around the bottle gains some energy from the bottle. B. Temperature of the milk drops as it loses heat to the surroundings. C. Saturated vapor pressure of the milk is equal to the atmospheric pressure. And D. Water vapor in the air around the bottle loses some of its energy to the bottle. Now the correct answer is option D. Option D. Water vapor in the air around the bottle loses some of its energy to the bottle. And because as it loses its energy to the bottle, it condenses back to liquid. Option A cannot be the answer because if it gains more energy, it should move faster. and therefore move in all directions, which is a characteristic of a gas. Option B cannot be the answer because it says the temperature of the milk drops as it loses heat to the surrounding. If it loses heat to the surrounding, the vapor in the air should get more energy and continue to move in a non-directional motion. Option C cannot be the answer because when the saturated vapor pressure of the milk is equal to the atmospheric pressure, this is boiling.